We're also going to need to know how we can combine capacitors to get a particular value of capacitance. The reason we always have to do this is even if we had all the money in the world and a giant warehouse to store these in, we can't buy capacitors of every possible size because they're not made in every possible size. This is the same way we don't make currency in every possible denomination. We don't make one, two, three, four, etc. dollar bills. We make a few different kinds and then you combine them to get the amount you need. The first way to combine these capacitors is in parallel. So here we can imagine all these capacitors, they are in parallel. The reason they are is because they all have the left plate connected to each other via this wire. So the top or left plates all share a connection, and their right plates all share a connection. We also have a battery connected to charge them up. We want to know what single capacitor would replace these four. The easiest way to answer this is to imagine that the four capacitors, which could have very different values of capacitance, are built with the same stuff inside, the same dielectric, and the same plate separation. If that were the case, the differences in capacitance would be entirely due to differences in plate area. So even though I've drawn these with the same symbol, maybe this is very big plates and this is very small plates and this is somewhere in the middle. The capacitance of each one would look like this. C1 is A1 times the permittivity of the dielectric stuff inside divided by D. C2 is A2 times the same stuff. We imagine bringing these capacitors closer and closer together until the plates touch. Now they all have the same value of D, they all have the same value of epsilon. What would the capacitance of this be? It would just depend on the area, and that would be the sum of all the areas that make it up. So we could say the total capacitance is this total area times epsilon over D. We could write that as epsilon over D times the sum of the four areas. But I could write this as the sum of the four capacitances because epsilon over D times A1 is C1. Epsilon over D times A2 is C2, etc. This is the general formula for how we combine capacitors in parallel. Their equivalent capacitance is the sum of all the individual capacitances. This also means that the final capacitance has to be larger than the largest individual capacitor that made it up. We also notice all the capacitors have the same voltage between their plates since they're in parallel, and this is a general rule for any circuit elements in parallel. If they're in parallel, they have the same voltage across them.